All right. Hello, everybody. Welcome to another SST weekly stream. So today we're going to be talking about domain-driven design. So before we get into that, I am getting an echo. Let me see what's going on here. Lots of echoes. All right. Is that better? Hello, hello. Hang on. Why is this happening? Oh, I found it. All right. Okay, cool. So before we get started, just a few housekeeping things normal. If you have any questions, just pop them into the YouTube. I'm going to be monitoring them as I'm doing this talk. I'll answer them as I can and as I notice them. The other thing is, again, topics for these streams. We try to pull from what the community is talking about. So every week will kind of reflect that. If you have any things that you are confused about or been wondering about or been hearing about and would like to see me dig into them, I'm happy to take that. And we'd love to actually do topics that are from the community, whether you think it's specifically ST related or not. It's probably something that we can do some research and present. So with that, so today's topic is a little different than what we normally do. So the topic today is domain-driven design. This is not something that's serverless specific. It's not something that's SST specific. It is a general programming concept. You can use it whether you're using SST, serverless, a traditional application. I think it makes sense in a lot of contexts. I want to talk about it, though, because I think it gets lost a little bit when you are working on serverless. And it is something that's very helpful for building a maintainable code base that scales to your business changing over time and different people coming in and just the usual ups and downs of building a product. It's a great way to keep your code base something that you enjoy working in. I think a lot of us have had experiences where we've started a new project and it's been really nice and everything's clean and fresh. And then you fast forward 1 year and it's suddenly not that fun to work in. Everything feels a little bit hard. You feel like you used to ship faster, and then maybe now there's a lot of stuff to work around, so you're shipping even slower. Domain-driven design is one approach to help address some of that. It's not going to solve all your problems, but at a bare minimum, it's something that I think most people should be following. It'll guarantee you a certain level of maintainability. And it's one of those patterns where as your product evolves, it should actually get easier to build features, not harder. And then, to me, that's a great test of, is a company on a good path? Is your team on a good path? Are things getting easier to build, or are they getting harder to build? If they're getting harder to build, you might be able to deal with that for a while, but you can see where it's going, and eventually you start to stagnate. And most people usually quit their jobs before they have to really deal with this. So, it's a very common thing in a lot of companies I've consulted at. I think very few get this right. So to jump in, I want to zoom out a little and talk about why this concept maybe gets lost a little bit when talking about serverless or in the serverless community. So I think with the shift to serverless, we threw away a lot of old patterns, which is pretty good because a lot of them don't make sense anymore. And they were maybe things that we used to have to deal with that we don't want to deal with anymore. So like things like microservices, right? If you're deploying serverless functions, the concept of a microservice and having microservices communicate isn't that relevant. People still do use this pattern, but for most people, not that relevant. Kind of good to throw that away. Things like containers, like we're not worrying about the complexity of containers and packaging stuff up. So serverless, because it's so different, it reset a lot of the ways we think about things. I think the downside of this is we've thrown away a lot of things that are old solved problems that we're now running into again as though it is for the first time. And it might feel like, oh, this is like very serverless specific, or I'm running into a serverless problem. But I think we're throwing away some of the stuff that, is good from like the previous non-serverless era. So again, it's not SST related. You can use this anywhere. I think it's a good concept to know. The other thing I will say is this is not So the phrase domain-driven design is actually just like everything in tech. There's like an official definition of it, and there's like very official patterns and official terminology that you're supposed to use and official ways of doing things. I'm not going to be doing that. I'm more presenting the concept of domain-driven design and like the ideas behind it. Not a prescriptive, like here are the exact ways you need to lay stuff out in your code base. I'm going to do a little bit of that, but I think a lot of people that are a little bit more hardcore about this pattern will look at some of the stuff I'm presenting and say, well, it's not exactly correct, but I'm presenting a balance of, following it to the T and being something practical that you can adopt in your application. Mouse just died. A lot of stuff going wrong this stream. All right. Okay. Let me scroll back down to my notes. Okay, so for this, I'm going to talk about the way I'm going to present this concept is I'm going to talk about the extreme of doing the opposite of domain-driven design, and we'll kind of step by step approach something that looks more like domain-driven design. And then from there, we'll jump into like a sample create SSC app where we'll try to model like a real project using some of the ideas that I talked about. So let me flip over to screen share. Oops. I want you to be on this side. All right. Okay. So I think the way to think about this is there's kind of a spectrum to start. Let me zoom in so you can all read it. And I think the spectrum is there are on one end of the spectrum, which is going 0 to 1. It's not be big enough. And let me make spectrum and 0 to 1. So this side of the spectrum represents how difficult is it from having nothing to going from having something. So the beginning of a project, when you're first spinning something up, or the beginning of a feature, how fast can you go from not having anything to having something that works? And at the other end of the spectrum is maintainability. Right. So this is, okay, once you've gone from 0 to 1, how do you go from 1 to 2, 2 to 3? How do you delete a feature if it turns out the business was wrong and they change their mind on it? And I think these things are somewhat at odds. I found that when you optimize for making it super easy to add a new feature from nothing, you tend to sacrifice stuff on the maintainability side. I think being on the extreme of either end of the spectrum is not great. If you think about a lot of frameworks that pitch like, oh, look how fast you can build, this Hello World app, you'll often find after using them for 2 or 3 months, it doesn't scale well to a real application. So you don't really want to be at the extreme of 0 to 1. That said, you also don't want to be in the extreme of maintainability. I think when you go to that extreme, you tend to over abstract certain things. You try to build these big frameworks for things that you end up never using, or you'd actually didn't know enough to build such a complex framework in the beginning. So the challenge with like everything in programming is there's a spectrum and you have to find where to land on it. So what I'm presenting today with domain-driven design is going to be somewhere in the middle. It's not going to be the easiest 0 to 1 experience. If you solely compare what I'm presenting to a lot of the other options that are out there that are pitching, look how fast you can build something, it's going to look worse, but it is going to outperform, on 6 months into your project, 1 year into your project. So it's important not to always evaluate frameworks by how easy is this to like get something into a database and display it on a front end. That's usually the most trivial part. The hard part is what happens when your business logic gets more complex. What happens when you run into new concepts that you didn't expect before? How do you refactor things? That's like where the tricky stuff comes in. So again, we're not going to go to the extreme of maintainability because most of my work has been at early stage companies. So my balance is more around how do we build something maintainable while staying pretty agile. And I find somewhere like in the middle to work pretty well. So before I get into the actual demonstration, I want to talk a little bit more about why maintainability is actually important. I think it sounds obvious. Maintainability is innately a good sounding word, but to be more specific, your job as an engineer is to give your company as many chances as they can to get something right. If, like I said before, if things are getting harder and harder to build, if a feature on day one took a week, but then 6 months in is not that same feature would take a month to build, you're kind of eating into your company's runway. You're increasing the cost of a mistake. So if you have a maintainable system, you can really lower the cost of mistakes, the cost of iteration, give everyone on your team more chances to get things right. It also allows reversing decisions really easily. When you have good maintainability, you know that you don't have to get everything right away because there's clear paths to refactoring and removing stuff. So a big part about domain-driven design is making it easy to change stuff and also remove stuff, right? Sometimes you build things where you know you just want to get something out there to learn more, and that's fine. But that doesn't mean you should ship like the most throwaway code possible, because throwaway code tends to actually be hard to throw away. You want to ship stuff that's easy to remove, easy to change. And you also want to have a good balance of code reuse. So I think, again, if you go to the extreme of maintainability, you start to optimize for code reuse where it's not useful. It's really brittle and the abstractions break. But you do want some level of code reuse. So when you know something has to change in a complex system, that there's a single source of truth, and you know if you change it in one place, anything downstream that's dependent on it will also get the changes, and it's not this thing where you're tracking down every little thing. Cool. So let me actually move my notes to my other screen so I'm not flipping back and forth. All right. All right. So for this demonstration, I want to kind of talk about starting at the extreme of the 0 to 1 and slowly moving towards the maintainability side. So let me clear my screen of this stuff. So if you think about what's like the most productive architecture you can come up with, if you only optimize for 0 to 1, like what is the absolute most productive thing you can come up with? It's probably something like this, where you have a database and you have a browser. And the browser, let's actually call this your front end. Okay, this is a single page application running on the front end on someone's browser. And the most productive thing to do probably is just to write from the front end straight to the database. So the reason this is productive is if you need to add a new feature, you just go to your front end, build the UI, and whenever there's events in the UI, you just write a query that goes straight into the database. There's no API. There's no middle layer to deal with. There's no transformations to deal with. You can kind of, this minimizes the amount of stuff you need to do every time you need to add a new feature. This obviously, I think, as you guys are probably reacting, this obviously is not a good model. There's a lot of issues with your front end writing directly to the database. So some of the obvious ones are, permissions, right? How do you prevent a front end from, let's say this is a B2C application, how do you prevent one user from reading data of another user if they can directly talk to the database? How do you prevent them from changing data from another user's database? So there's a question of, let me write this down here. So, how do we do permissions? How do we prevent people in this model from accessing stuff and changing stuff they're not allowed to? The next issue is side effects. Let's say some of these things trigger, some of these events that happen in your system need to trigger other things. So let's say we're building a project management app, and when you create a new task, it should send an email with a notification of whoever you assign that task to. You can create the data model in the database, but if you need to trigger an email, it's a little bit trickier. You can have your front end talk directly to like an email service that does it, but you can see how this, again, is kind of messy and definitely not right. Then the next thing is duplicating logic for multiple clients. So in this example, this looks like it makes sense because there's only one front end. Let's say this is a web app. Now let's say you have an iOS app as well. So you can have your iOS app also talk to your database, but you're basically duplicating all the logic you have in your web app and your iOS app. So that thing I said earlier about creating a task and then triggering an email, that's now something you're going to have your iOS app also do. So duplicating duplicate logic, that's another issue. Let me space this out a little bit better. All right. And the last thing is not all of your front end is now highly coupled to the data model of your database, right? This goes back to making mistakes and making mistakes reversible, or change how you do things. Let's say you made a mistake in your data model and it needs to change. You can go now do that in your database, but it instantly breaks all your front ends, right? All your front ends are now outdated. So making any kind of change, it's highly coupled. If you need to rename a field, for example, you need to go and update in your database, update in your web app, update that in your iOS app. You can get used to this pattern, but it doesn't necessarily have to be this way. It is this tight coupling can create a lot of issues. The other issue is, the data models in the database might be really complicated. You might optimize for certain things. It might not really make sense immediately to the front end. So you're kind of pushing all that burden to the front end to now understand a potentially complex data model. So I think of this as your data model is leaking, right? The data model you have in your database is now leaking to your front end. Your front end is aware of the implementation details. It's probably aware of these fields that you have in the data model just to allow certain things to happen that the front end technically shouldn't care of or be aware of. So those are some of the issues there. Again, so I think in the comments, Mongo, Fauna, Hasura have, basically built this model as a service. And it's because they were optimizing for the 0 to 1, right? If they think about it as some applications are very simple CRUD applications, they're just putting data in, taking it out. Let's just make the API layer go away and have the front end feel like it's effectively talking to the database. These applications, again, for something very simple, this can work, but you'll see that bigger applications, or you might think your application is simple and very quickly realize like you need a lot of these things. To be fair, some of these services give you little hooks to do some of these other things like permissions, side effects. You probably will still have the duplicate logic issue. You probably still will have the data model leaking issue. So this model is very productive, and I actually for years built my own system that worked this way, sort of. Not exactly the simplistic, but ultimately like the back end, front end, everyone should have the same data model. And it's hard to deny that it is very productive, but it is very hard to maintain, especially when you're trying to add a lot of new features, iterate on existing ones. Every change means changes everywhere. There's no blast zones to contain some of the changes. So I think the natural place that people go to after this is, all right, we obviously need something in between the database and the front end client so we can implement some of these issues in there. So let me clear this out. Actually, no, let's leave this here. Move this down. So typically you'll have an API. And this actually addresses a lot of these problems. So with an API, you now have a layer between your front end clients and the database. So this is good because now you can structure things so that this data model leaking issue doesn't happen anymore, assuming you design your API well, and we'll talk about this more a little bit later. You don't have the duplicate logic issue anymore because all your logic is implemented at the API, and your clients interact with a simplified model. So they can say like, create task, and the API will take care of, writing it to the database, triggering side effects like sending emails. The API can also implement permissions. So it can see that, okay, based off who's making this request, let me see what they're trying to do. And let me like halt everything if they don't actually have proper permissions to this. So this setup is actually, it's kind of, we can leave this here. This setup is probably what's most common. You implement an API layer. That might be a REST API. That might be a GraphQL API. Specifically in the serverless and SST world, this might look like an API gateway that's pointing different functions. And depending on what route the function is handling, it will, talk to the database directly. It'll trigger side effects. It'll do all this stuff in there. So this is a lot better than the other model for maintainability. If you're refactoring any of this business logic, you do it in one place. You don't have to worry about your front-end clients. They're safe. If you make breaking changes to your data model in your database, you can still make that backwards compatible with all your clients. Even if you're not running a public API, it's still pretty helpful to have backwards compatibility for your own clients. It's helpful to be able to iterate on your API without being forced to also update your front end. If you're deploying like something like a native app, you can't really force everyone to update as easily as a web app. So you kind of always need to have some level of backwards compatibility. So API layer helps create that. So I think most of these issues are solved, and it can feel like this is basically good enough, but there are still some issues that come up, especially in the serverless world and the serverless architectures, because the API is talking directly to the database. You kind of have a similar issue as before. Your data model is now leaked to the API. Your APIs are now really aware of certain database details. All the same issues I mentioned about your front end talking directly to your database, you now have in your API layer. This might not immediately seem like a problem, but it very quickly becomes a problem when you have events that happen outside of a request coming in from a user, right? So you might have other things that happen. You might have cron jobs. You might have scripts people are running off. You might have webhooks you're receiving. Maybe webhooks isn't a great example because that's probably still coming to the API. Actually, no, I will include that. So let's say you have an API method for creating a task in this project management app. If that triggers an email, okay, cool. Let's say you are you're importing a bunch of tasks. Someone's like migrating off of a different project management tool onto your project management tool, and you want to write a script that imports all their old issues. You now need to duplicate the logic that the API is doing. So these things now will also need to talk directly to your database. So whatever it's a cron job, it's a script, it's events coming from a webhook, whatever it is, you're now duplicating logic between your API, cron, scripts, etc. So if you go in and you need to change some logic, you need to say, hey, this email feature sucks. Let's actually turn it off. We don't want to notify people of emails. You now need to go remember, okay, I need to turn it off in the API when a task is created. Oh, but we also have these like random scripts and cron jobs that we forgot about. Let's also make sure we go turn it off there. So again, you kind of lose that concept of a single source of truth and you're duplicating things. You can kind of work around this if these things are actually just also talking to your API, the cron, scripts, webhooks, etc. That kind of ends up being a little clunky. You need to now worry about exposing certain details publicly and making sure those aren't callable. And some things like batch, some actions that are more batch related don't really make sense to go through an API. So you still have this issue of, stuff is still duplicated. Yeah. The other issue that I can think of is your API and database are coupled here. This isn't that common of a worry, but if you need to change certain parts of your system to be in a different database, let's say for whatever reason you need to, or actually this is a pretty common example. Let's say you need to like search through your tasks. That needs to now talk to a different database because your primary database is not a good search database. Your API now needs to talk to that different thing. So you can kind of see how the bloat ends up showing up in your API, which should be pretty lightweight and really focus on shaping data for your clients. Also, the concept of supporting multiple API formats. This, again, isn't that common, but if you are serving a public API, you might want to serve a public GraphQL API for people that like GraphQL and get it. But you also might have some customers that just want a traditional REST API. So if you need to support multiple APIs, again, you're duplicating the logic between all those. It gets very difficult to maintain. All right. So how we address this is now we're kind of shifting more into the domain-driven design model. So let's kind of do what we did before. I don't know why the select isn't working the way I expect. Let's move this down. It's where am I right now? DynamoDB scans are a pain. I'd rather use RDS selects instead. Yeah, I think I find myself doing this a lot too, where I have a primary data store that is replicated to a secondary data store, and I want some actions to use a secondary one instead of the primary one. I think DynamoDB is great for operating like very transactionally on like single item updates and single item reads. But if you're doing like complex filtering and sorting, like an admin type view, you probably want something that's more suited for that. So I've been actually mirroring all my DynamoDB data into a database that supports SQL for those. I don't use it often, but it is nice to have that as a backup when you need like a very complex query pattern. Okay, so this next iteration we're going to do is it's my flavor of domain driven design. Like I said, it is not the canonical way of doing it. Like I said, I think a lot of people look at this and say it needs to be a lot more complicated. I personally don't think it does. I see the arguments for it, but I feel like you can go pretty far with what I have here. So the next iteration of this is where you have a domain layer. And the question is like, what even is a domain layer? The way to think about your domain layer is it is just the pure implementation of what your business is. Your business is probably composed of various domains, and all domains is just an area of concern. So a project management app might have a user's domain. Let me write this so we can keep track of it. Have a user's domain, you might have a project's domain, right? You might have multiple projects in your project management app. You might have tasks. So you might have like these 3 domains to manage. I think this is actually the most important part of your job as an engineer. You need to look at your business, understand it pretty well, and break it up into domains that make sense. Just think about what are different parts of the business, how can we separate them, what functions go in each part of it. Like in the user's domain, of course, we need to be able to create users, we need to be able to delete users, we need to be able to reset users' passwords, like all the actions that we're able to do. And these actions should make sense to non-engineers as well, right? If I go and show anyone in my company, like, oh, here are the domains and here are like the things that happen in each domain, it should make sense to them. And you should actually work with domain the reason it's called domain-driven design is you typically work with domain experts, people that understand a space really well, to come up with this layout. I think so. Practically, what this looks like in your code base is just a collection of modules and functions. And it's the way that how I implement it, and then the way that create SST will bootstrap a project for you automatically. So like you create a module for every single, by module I mean like a folder or a file for every single domain, and in there you have a handful of functions that are helpful and make sense to people. This is a pure implementation of your business logic. It is not aware that it's running in a serverless context. It's not aware that it's using GraphQL. It's not aware that it's using a REST API. It needs to be the bare minimum to execute different actions in your business. This will take care of talking to the database and storing your data in different ways and then retrieving it. Let me just check my notes here. So it also handles things like, when I say business logic, what I mean by that is things like validation. Is the data that we're about to put into the database correct? Is it shaped correctly? Different calculations. Sometimes you call a function with a simple set of arguments, and it needs to calculate something more complicated based off of your business. There's other business rules, like when this happens, this other thing also needs to happen, or this thing is not allowed to happen unless this other thing is in this state. So your domain layer should really just be a collection of modules and functions that implement your business. A test that I like to use to see if we're doing this correctly is, can I now use these functions and build a CLI? Like, can I use my entire product and my entire business through a CLI? It should be possible, because your CLI just ends up being another entry point that just very simply calls into the domain. So you might have like a CLI command to create a user, and that I'll just call into the create user function in your domain. So you kind of think about it as I'm going to build a bunch of core libraries that are going to be used for a CLI. But of course, that can be used for your GraphQL API. That can be used for your cron job, your script, your webhooks. So what's great about this is you now have a central place that is very decoupled from any entry points of your application. This is a pure representation of your business. You can, whatever changes, you can change it in the domain layer. Of course, there's going to be some refactoring here, and some of it might be hard, like if you're changing to different data models. But everything downstream is unaffected because you can always return the same data model. So the example I was talking about earlier where most of my reads and writes go to Dynamo, but for some reads and writes, I want to use RDS. My domain layer can handle, okay, for a user get, that's going to go to Dynamo. It's going to be pretty effective. But for user search, that's going to go to Algolia. But the domain can return the same user object in either case. And your API is pretty unaware of those implementation details, right? It doesn't need to know that you're using Algolia under the hood. You can start off doing everything in Dynamo and then over time move half of those functions into Algolia, and everything downstream is unaffected. This is a really great way to build systems that you can maintain over time. You can think of each layer as kind of like a blast zone. So if you like make a huge mistake in your domain layer, that's fine. Go fix it. Your API, cron job, CLI, these are all unaffected, or you can make them unaffected. And similarly, you can make mistakes in all places, right? You might have poor API design and you want to change this. You can do that without affecting these other things. So let me look in my notes. Yeah, so again, the key thing with the domain layer is you can call into it from anywhere. It is unaware of the entry points. You can implement all the things you need to do in there, talking to your database, triggering side effects, implementing permissions as well. I actually prefer implementing permissions in the domain layer instead of the API layer. Again, it's so I can get those permissions to be consistent across all entry points, not just the API. The data model leaking. So your domain doesn't have to return database objects directly. I think practically it's okay to do that for a lot of situations, but you can create a simplified version of whatever you're fetching out of a database and send it forward. That way, if you're using multiple databases, everything for downstream is using a common format. Cool. So like I said, this is a pretty simple version of what domain-driven design looks like. You can keep going. You can keep adding more layers, right? You can say there's like, I know some people, there's another pattern, which is like a flavor of domain-driven design called hexagonal. I forgot exactly what it is, but it's like a more sophisticated version of this. They have like also like a persistence layer. And that way your domains are like unaware of where they're fetching the data from. I think practically to start, like you don't need to go this crazy. I think just having a domain layer separate from your API layer is a great place to start. Yeah, it looks like one of the comments someone's mentioning that. So yeah, it's a great place to start. I think most people is already going from what you currently have to going from this is already going to give you a ton of the benefits. And as you understand this better, you can start thinking about, okay, do I actually want to abstract with more layers? Again, I think this is a good initial goal. So from here, let's jump into actually doing this in practice now that we understand the theory. So I didn't prep too much for this, but I thought I keep talking about this hypothetical projects app. I can show how I go about implementing that with domain-driven design. So let me spin this up. I'm going to use, let's see. Okay, this should be visible. Let's make a new create SST. Should we go minimal? No, let's get the whole thing. So create SST does set up a domain-driven design flavor project. Let's wait for this to finish. I think, and the reason I really wanted to make this video is it feels a little, like I said, remember that spectrum of making 0 to 1 easy and making maintainability possible. if you look at the CreateSD starter, it might feel like, hey, this feels a little more complicated than some of the other simpler things I've seen. But again, the reason is because we are following this pattern, and our goal is really to give you applications and structures and patterns that are going to last years. We're not interested in just helping you ship your prototype in 2 months and then kind of being screwed after. We want to make sure we're really focused on these long-term code bases. So cool. Let's kind of look through. I've shared some of this in my other videos, but we'll go through this again. So the key thing here is we have this core folder, and this is where the domain layer is housed as a core of your application. It's really unaware of GraphQL. It's really unaware of anything that's used outside of it. Just again, that's where your pure business logic goes. And separately, we have a GraphQL layer, which is where our API goes. Of course, you can add more stuff here, right? You can add like a REST handler. You can add your cron job, etc. But everything in this functions section is actually just going to call into core. There really should not be much business logic here. If you look at the code in here, it should kind of be really, really small. It should really just be importing functions from core and calling them into each other, or calling into each other. It's a question here: how do you deal with situations where 2 or more domains intermingle or have blurred lines? Yeah, so that's a challenge of domain-driven design. It's defining boundaries. So it's okay for domains to call into other domains. You can kind of cheat a little. Again, I'm not, like I said, I don't follow this stuff to an extreme. If you do want to look it up, though, there are domain-driven design terms like aggregates, which kind of compose together a bunch of different domains into a higher level concept. There's a few different things like that. It's okay. It doesn't have to be perfect. You can have one domain writing directly to the database model of another domain. It's not ideal. You don't really want to do that, but there are situations where you do need to do that. So don't worry if you're not following it perfectly. I think you'll find that 95% of the time you will be following it perfectly. And for those small cases where you kind of do need to have domain intermingling, it's not a big deal. You can always expose functions on one domain that are maybe explicit to another one. The other thing I will say, though, if you find yourself with one domain that is now importing pretty much every other domain and calling into it, you probably need to invert that. And my last video with the event bus, that's actually what that was, right? It was you might have 5 domains, and one domain just publishes events. The other domains themselves can subscribe to them. So there's not like a direct coupling between them. So I think you'll find that with an event bus, you can mitigate some of these situations. So because it's a CreateSD, we already have this sample in here, but I'm going to get rid of it. Let me also just run yarn so these errors go away. For now, let's get rid of the article. When you're starting a new project or a new feature, you can kind of start in different places. You can start at your API by defining your API first, or you can start at your domain and kind of define your domain first. I think I usually start the domain, but sometimes I'm more confused about the API than I am about the domain. So I want to knock out the API first. So that informs me on how I should structure the domain. Just depends on the situation. But for this, we'll start with the domain layer. So again, just to kind of review the example that we're going to do. So this is a project management app. I picked this because I think we're all kind of familiar with what that is. So you have different projects. Each project can have tasks. You can create tasks. You can assign tasks to users. There's also users, I guess. So kind of something like Linear, you can imagine, follows this. Linear, Trello, Jira, whatever it is you use. So cool. So if we think about this, okay, what's the first place we want to start? Maybe we start with user, because that's pretty simple and pretty common. We might have a user domain. And when I go about this, I don't really worry about the database or any of the storage. I just like to mock everything out and see if everything fits together nicely. So if I think about a user, in this approach, I think people refer to this as a type-driven design. Like I define all my types in the shape of all my functions first. And once they all fit together nicely, then I go and do the implementation, which is usually pretty easy. So you can imagine a user has a user ID. They might have an email. Maybe they have a name. And we Probably want to have a function that lets you get a user from their ID. Again, remember, we don't have to implement any of this first. I don't usually use function type annotations, return type annotations. I believe you should let inference do that, but for mocking, this is a good way to do that. Actually, I guess we don't have to do that. I can just go return undefined as there. So this is not implemented. Okay, so we definitely want to get a user from their ID. We probably are going to want to list the users too. Oh, no, that doesn't take an argument. So this is going to be, let's see, the Copilot in action. Very nice. This is going to list list of users. Makes sense. We might want to get a user from their ID, from their email. Cool. We might. Is there anything else we might want to do with the user? That's probably it. I'm not going to go into auth right now. We'll just pretend auth doesn't exist. So get a user by ID, list users, get a user from email. Okay, that makes sense. All right, then let's do the next thing, which is, okay, users can create projects. So again, we'll have something similar, project interface. We'll have a project ID. We'll have project name, right? That makes sense. Let's maybe have let's have some times. So, okay, when was it created? Let's say when it was deleted. So we want to store that as, we don't want to actually delete the project. We're going to store the deleted timestamp. Cool. So now let's think about some of the functions to implement on a project. And this is where I want to cover another topic. I think I've heard this phrase as the anemic domain model. It can be tempting just to do this. Function update. And function, from ID. You can say, okay, domain model done, or domain module, project domain module done. If you want to update the project, you can go and call update, pass on project and update everything. If you want to get the project by ID, you can get it. Now you can do whatever you want. This is actually really bad. This isn't actually solving any problems for whoever's calling into this. They still need to be aware of all these specific details about, when I want to delete the project, I actually need to set the deleted timestamp. You want to provide very specific business actions, right? If you're talking to someone else that's a non-engineer at your company and you say, oh, we have the capability of updating a project, that's not as useful as saying we have the capability to delete a project, to rename a project, to create a project. You want to have very specific, granular actions that can be used. You don't have to go crazy, right? Wait for an actual use case to add it in, but you want to have specific actions that make sense. This makes sense for a lot of different reasons. Like, this is also really great for auditing. If you have something that records all the domain functions you're calling into, and you just see a bunch of update functions, update project, update project, update project, that's not as useful as saying, okay, project was created, project was renamed, project was deleted. So it's useful to have very granular action. And this actually goes to the API side as well. I think I see a lot of people using GraphQL in a very CRUD manner, create the thing, read the thing, update the thing, delete the thing. The whole point of bothering to use GraphQL is so that you can have really sophisticated actions that you can define and be really granular about that. So in this case, we don't want to just have an update project. We want to think about the things that we actually want to do over the lifetime of a project. So we probably want to create a project. And this is another nice thing, right? We can say explicitly what a project needs to be created. We don't just say like, oh, we take the whole thing and up to you to figure out what's actually required. And in this case, let's say it really just needs a name. Anything else? So what else we want to do? We want to maybe rename the project. That will take a project ID, project name, or the new name. And I'll rename it. We want to delete the project. Well, Copilot is reading my mind. Sorry. Copilot is not perfect. You still got to pay attention, which sometimes I don't do. You want to just pass in the project IDs here, not the full project. This is looking pretty good. So I think creating, renaming, delete the project, that makes sense. Here's another little thing. You might have seen me do this in a few places. It's also in our starter. I follow this pattern, and maybe this is controversial, but I don't know. I like it. I do this, and it's kind of like, why are you exporting itself from itself? The reason is, again, when you're thinking domain-driven design, so in other areas, let's say we have this cron job. Here, you can think of, okay, I want to do something with a project. Let me just type project, and I can go see. I forgot to export all these. Should all be exported. For the warning as well. Okay, so now you can go see, oh, what can I do with the project? I can create, I can get it from ID, I can delete, rename. So this is nice to have. I know some people like to import very specific functions they use, but I find that you kind of lose the namespacing, like create what. So I tend to put it like this. Of course, you can. Actually, I messed up here. This should just be rename, and this should just be delete. We don't need the project. It's redundant. Delete's a reserved keyword, so let's call it remove. Yeah, so going back here, you can see create, from ID, remove, rename, etc. Of course, you can name your functions more specifically, import the functions more specifically, but I like this pattern of exporting the whole module, and then someone can use the whole module. There are some tree shaking issues that happen, but typically with your own code, this doesn't really add up to anything significant. Okay, cool. So I think project looks done for the most part. This seems pretty nice. Now let's think about task. A task domain, and you might argue that a task is actually not its own domain. It belongs under the project domain. I think that's fair. For this example, I'm going to make it its own domain. So let's do that same thing I did before. Close this other tab. Okay. So what can we do? Let's look at the shape of the task first. So a task, again, task ID, of course, a name. Whoops. Project ID. And I have a description. What else can I have? I think I'll have the usual timestamps, right? When was it created? When was it completed? Be optional. Maybe it was archived too. When was it archived? I think that's, maybe it has an assignee, which is going to be, it's going to point to a user. This as well. I actually usually name this just info so that it doesn't conflict with this export, which I probably need to do here as well. So let's rename there. And I don't think I did this with user at all. So let me user from user. All right. I rename this to info. And I didn't export any of this. Okay. Task. All right. All right. So we have all these things. Of course, we're going to want to create a task. By the way, another thing I do, which I haven't been doing in this so far, but I actually typically just take a single input object. I will specify what it needs and what's optional. So to create a task, it needs to be created under a project ID. So of course, we're going to need a project ID. We don't need an assignee ID. It can be as unassigned. Let's say we need the name at least. That should be enough. The rest of it are fine. The rest of it's fine. What else can we do? We can complete a task. So we might just take a task ID here. Anything else we can do? Let's say we can update the name, or I guess we can rename. Ends up looking a little bit similar to Sorry, 1 second. Similar to the project. Is there anything else we want to do? Oh, maybe we want to archive it as well. No, I should copy this guy. Archive. Now let's kind of explore everything we've done. So cron, we have project, we have task. These import on their own. Task, we have project, we have user. So we can, create project. We can create a task under the project. You can see here, like, we can kind of explore all this and think through, does this make sense? Yeah, this all makes sense. Forgot to maybe assign a task. Maybe try that. So here we would assign a task. And see here, I'm calling this user ID because I think from the perspective of a caller, you're thinking about this, I'm assigning this to a user. But under the hood, we're actually saving it as assignee ID because that actually makes more sense in the data model. So it's an example of how you want to really think about who's calling into this. So in the domain layer, who's calling into the domain layer? How are they going to be thinking about things? Same thing in the API layer. Who's calling into the API? How are they going to be thinking about things? But cool. I think this is pretty good. Let's say we have a user that we created. Had the ability. We didn't have the ability to create a user. Forgot that. So see, this is pretty useful to help you think through what you need to do. So we just create them from their email and nothing else. All right. Create. Our user at example.com. We have our basic structure. This all seems like it makes sense. We can create a task. It's also like assign them. Assign this task ID, user ID. Cool. You can, at this point, you can start writing tests. If this is how you want to develop, you want to write tests against your domain, you can kind of test all this stuff, which I guess it actually won't work because you don't have implementation, so you can't do that yet. But I guess from here, you can start to go and implement some of these functions. So for project create, you might create an ElectroDB entity. You might save the project and under, you might create it and save it under there using the ElectroDB create method. You might have rules for the name, right? You might say the name needs to be at least 3 letters long. It can't be more than 10. This is a good place for you to implement that. So all like the business specific logic can go in here. Those details don't really matter right now because we're thinking about things in the high level. The implementation typically tends to not be that complicated. Again, this depends on the feature you're working on. Maybe it is really complicated with the feature, so you want to get that out of the way right away. But more broadly, you can kind of think more structurally in terms of different entities and how they relate. And from here, you can go into API design as well. And I want to show you some interesting things you can do here. So I'm just going to put everything under one file. Just keep it simple. So let's import our builder. Okay, so we think about our API, what do we want to actually expose? So we definitely want to expose a concept of a project, right? So export const project type. Builder, this is going to be an object ref. It's going to be backed by, and this is where, those interfaces, wow, what is going on here? A lot of things in AWS called project. I'm going to import this manually. For project, it's backed by this. export this interface. All right, and now we can implement what the API looks like. Please forget the syntax for this. Is it like this? It is. We're going to have an ID, of course, because everything GraphQL pretty much. Hang on. I always forget how this works. Let me. Oh, right. This, we're going to implement fields on here, and we're going to have an ID. This is all wrong. Fields, we're going to build fields. Now is it going to work? All right, there we go. So we're going to expose an ID, and this is going to pass through from the project ID. We're going to expose a name, of course. Expose a name. String. What else do we have in our project that we can expose? I want to show a concept here that I think will be interesting. Okay, so we have this times created times deleted field, right? So we can expose that as created at. It's an example of how. You know what? Let's not do that yet. Let me show you a different concept now. So in our data model, we don't hard delete anything. We only soft delete it by saving a timestamp that, okay, this was deleted at this time. So of course, we can expose that to the front end as is. We can say deleted at and say this is a string for now, whatever. Project, what is this? Project times deleted. And it's nullable. And we're going to convert that to ISO string. There's better ways to do all this, but this is fine for now. So now someone can fetch this project and they can check this field to see if it's empty or not, to decide whether it's deleted or not. So the issue here is you're kind of leaking implementation details to the API, right? You chose to implement that as a deleted at timestamp field. If someone is consuming your API and they're wondering whether a project is deleted or not, is that really the best way to express that? I think what would be better is if you exposed a deleted Boolean. Sorry, I'm a little bit rusty on this stuff, but expose a Boolean where you say project times deleted does not equal null. Right, so this is actually a much better API. The front end can now just check, is it deleted or not? It doesn't really need to know about this underlying concept of, oh, we're actually storing a timestamp, and the timestamp is empty, then the project is deleted. This lets you later change the logic here. Whether this is deleted or not, it lets you change it to be something else without affecting your front end or having to update your front end. So this is what this concept of leaking implementation details is. You want to make sure that you're not just kind of blindly just taking your data model from your database and just passing it to the front end. You want to think about what useful things can I actually expose. It's the whole point of having an API, right? And if we go back to that model, otherwise the front end might as well just be pulling data out of the database. So you can do useful things here. And this is a bit trivial of an example, but this should inspire you to think about different areas that you can kind of lie to the front end about exactly what the shape of the data is, but lie in a useful way. Okay, cool. So the next thing is projects have tasks. So of course you want to have a tasks field. And we can't actually implement this yet. So I'm going to leave this blank for now because we need to return a tasks type. Do the task type now. Builder, object ref, task info. Let's call it task fix this, implement. Not going to mess it up this time. Fields. Okay, so task is probably pretty simple. Expose a task ID. I'm not going to go through every single thing here. Name p dot expose string name. Let's say there's the assignee, which is going to be a user, which again, we can't implement this yet. All right, cool. So now that we have that, let's actually implement, we can go back and implement this now. So this should return a list of task type. And we can resolve that by, oh, turns out we don't know how to resolve it because we don't have a method to get a list of tasks for a given project. So we need to go back and now implement that in the domain. That's kind of why I'm saying it's helpful to implement just the shell of your domain first and go back to your API and think of the API. They'll kind of, it's a nice cycle where then it'll give you information about what else you need to implement in your domain. So if we go to the task thing, we might want to export a function that is export function for project. And here, this can take a project ID. And again, we don't have to actually implement this right now. So, I mean, this goes back to an earlier question, right? These domains are a little bit intermingled. Tasks kind of are related to projects and vice versa. There's a question of, should this function actually go on the project domain where when you might expose a function in the project domain that says tasks for project or project.tasks, and you pass in the project ID and get the tasks. You could definitely do that. It really comes down to your situation and what exactly you're modeling. And my rule of thumb is, depending on what the return type is, I like to store it nearby in the module of the return type. So in this case, we're returning tasks. So I'm actually just going to put the function in the task function, task module. So now we can go back and import this and use it. Project task dot for project. And this will take a project ID, which we can just pass through. Nice. So now we have a nice project API where you can fetch a project. We haven't implemented the query part yet, but for a given project, you can get the name, the ID, if it's deleted or not, and the tasks for it. We'll just kind of quickly implement this for user as well. So user type, user info. Might have not exported this. Yep. User ID, name, just throw an email for fun. Nice. So now we can say this field assignee is a type, user type. Let's resolve that by getting the user from the task assignee ID. And so this works. Cool. Then we can kind of implement the entry points to all this, which I also forget how to do this all the time. So query fields, I believe it's like this. Say, let's start with the project. It's going to return a project. It's going to take some arguments. So we can say it's going to take a project ID as an argument. It's going to be a string that is required. And to resolve it, we are going to, let's see, working here. Args dot okay, and we need to return this. No, we don't need to return it because our what's his error? I think this is what someone was pointing out before. Project. Again, this is why type-driven development is pretty nice. You can just kind of define the shape of things and work out the kinks. I didn't waste any time doing the implementation. Okay. So I was kind of inconsistent about here. Sometimes I took an object, sometimes I just took parameters. All right, so now we can query a project by passing a project ID, and then from there we can go from the project to the tasks. Cool. So you can imagine, okay, you keep going on and you go and implement entry points for tasks, entry points for users, queries for users. You can implement mutations as well for creating. Let's do a mutation really quick just so we can demonstrate. Mutation fields. We're going to have a create project mutation. It's going to return on a project type. I'm going to take some arguments. Name. And to resolve, we're going to call into this create project thing. Okay, so now we have a mutation as well. I very quickly just want to see if we can look at the GraphQL stuff. I forgot to log into stuff earlier, but let me do that now. One second, SSOing in. All right. This actually might take too long to deploy, so we might not actually be able to demonstrate this, but I guess let me try it. Yarn start. Let this run as I continue to talk. Okay. So anyway, yeah, so you can imagine like continuing to flesh this out, building your full API. What you'll have at the end of this is you actually have a fully implemented API. You won't have a fully implemented domain layer. You just have the shell implementations that we have here. But you can imagine going into this, you can do it with confidence. You know that, okay, at this point, you just need to save data from the database, pull it out. Once all that is implemented correctly, everything works. What I like to do after I implemented that stuff, like let's say I save everything in DynamoDB, I implement all these functions. This is where I start to write tests, and we're going to do a full release on testing with SST at some point in the next month. And then we'll kind of show you how I do end-to-end integration tests through the GraphQL API, which effectively tests all these layers. It tests the API layer, it tests the domain layer, tests any kind of like asynchronous function stuff you have going on. But yeah, from there you can go on. In the future, if any of this stuff changes, you imagine, okay, I don't want to store my users in Dynamo anymore. You just have to come to this file and re-implement these functions. It's going to be some work, right? You have to re-implement each of these functions, but the rest of your system is totally unaware that this happened. So this is what I meant by a blast zone. You have a blast zone for this domain, and you can make whatever changes you want in it as long as you return the same things and you implement the functions correctly. The rest of your system can continue to go on. And this is what's key to building code bases that are maintainable. You want to be able to confidently make changes without it being this full rewrite of everything. I think I see a lot of companies where every couple months they'll kind of rewrite a large portion of their code base, and there are situations where you're forced into doing that, but it shouldn't be that common. And I think as you get more organized, you can, you'll notice that deleting stuff or changing stuff ends up being a lot simpler. Cool. Let me see what else I have in my notes. So a quick question, when comes the ElectroDB stuff? So in this talk, I wasn't actually going to go into actually implementing this stuff with Electro. I probably will do that in one of the other sessions. I think that deserves like a whole thing. That's a great thing to talk about. I actually didn't have that in my notes for different topics that I can do. Let me add that Dynamo, or I guess Electro DB modeling session. That's something we could do, and that'd be fun. like share this project code. I can definitely share this. I don't know if this is that useful because if you do create SST, you basically get all of this. It's not this project task user example. It's like our little like article, like a little article sharing site example, but it's exact same structure. Having gone through this, though, I think we probably should change our tutorial to doing this. I think this is like a more fleshed out example. Another question, do you mind giving more details of the Lambda optimized GraphQL server shipped with the starter? Yeah, so I can talk about this a little bit. Not really on topic, but whatever, we can get into it. So I've mentioned this a few times in a few different videos. So we don't use Apollo, which I think a lot of people expect when they use, like if I'm going to use GraphQL in Node.js, I should be using Apollo on the back end. We don't do that. We use our own great GraphQL handler. And that might seem weird. Like, doesn't that seem like a lot of work? Is it well tested? And it seems like, why are you bothering building your own GraphQL handler? And the answer is we're actually not doing too much here. But let me start with the reasons. We actually did start with Apollo. We had something like this where we had an Apollo. I don't remember exactly their syntax. It's something like this, very similar. And that creates like an Apollo server. And if you watch my other video on function bundling, I actually use Apollo to talk about why a lot of libraries that are not made for function environments, you should not use them in function environments. By default, the way the Apollo handler works is, let me like kind of write this out. It actually spins up a full Express server first. Then it'll pipe events through using another library that like does like a Lambda to Express conversion. Then it triggers the Apollo stuff, and then it goes back. Then it goes from Express to like a Lambda response. So one, at runtime, these are a lot of steps that are not necessary. I get why the Apollo team did this. It lets them only interface with Express, and then you can deploy Express anywhere because there's lots of plugins to make Express work in Lambda, Express work in whatever environment you want. But it's not really optimized because at runtime there's a lot of steps that are happening, and this does add weight. More important though, it adds weight to your cold starts. So one, bundling all of Express into your function is pretty heavy. Express pulls in a lot of like really complicated big libraries that you don't need. And also even the Apollo library itself pulls in a lot of stuff. And if you watch my function bundling video, I kind of go through bundling with or analyzing a function that's using Apollo and seeing how big the bundle actually gets. The smallest I could get an Apollo bundle was like, I think like 4 megabytes or something like that to start. At that size, you're already kind of getting close to a 1 second cold start time, which isn't great. That's why we ended up saying, okay, are there alternatives to using Apollo? And at first it's like, okay, that seems crazy. It seems like a lot of work to go and build our own GraphQL server. Turns out it's not a lot of work for 2 reasons. One, GraphQL.js does most of this work. This is a library that Apollo actually uses under the hood. So Apollo is mostly just calling into GraphQL.js to now trigger your resolvers, all of that stuff. It's not fully complete. There are some like convenience things that people are used to with Apollo that GraphQL.js does not do. But there's other really nice library called Helix. So Helix is a thin wrapper on top of GraphQL that kind of provides some of the schema stitching stuff and things like that you're used to, like the context pattern, things like that. So all we're really doing in this create GraphQL handler is, so let's delete all this. We're piping an event from Lambda to Helix. And that is more or less just calling into GraphQL.js, which is processing. And then you get the response and you send that as a Lambda response. And this is a lot faster at runtime. The cold start, I think I can get this down to like, I think for a base, like close to one megabyte. So the cold starts are roughly around 500 milliseconds for this setup. My threshold is around 500 milliseconds for what's acceptable. I think anything larger than that, you're going to start to see users notice. Even with 500 milliseconds, that still feels like too slow, but Again, better than the Apollo setup. And yeah, we could actually even drop Helix and kind of implement some of this in a more efficient way, which we might do, but there are some benefits to using Helix. Helix is built by the great people at the Guild. If you use GraphQL, you've probably come across the Guild before. They maintain a lot of really great GraphQL tooling. I think a lot of it is better than the stuff coming out from Apollo. Like GraphQL CodeGen, GraphQL Envelope, which is a nice plugin system for GraphQL. We haven't integrated that yet, but Helix provides us an easy path to doing so. So yeah, that's why we built our own GraphQL handler. Again, seems crazy, ends up not really being that crazy, and makes a meaningful difference to your cold starts. Question: which folder did you put the interface files? Yeah, so that's in the services core, as another comment mentioned. Again, if you watch the video from the beginning, all your core business logic goes in core, completely decoupled from the rest of your system. And yeah, that is it. So I don't think I have anything else in my notes. I want to talk a little bit about what we're going to be talking about next week. So I actually decided already to talk about Edge stuff next week. So this will cover Edge functions. It'll also cover stuff that doesn't seem related but is related, which is SSR. So you might be hearing a lot about like Edge compute, Edge databases, SSR, which is like a front end tactic. All this stuff is really confusing. It's kind of hard to put all this together and understand how it fits in. So I'm going to go over step by step, like each component of this, how it all fits together in the architecture. I actually think that Edge stuff is not as exciting as it's made out to be. There is interesting places to use it, but it's a lot more narrow of a use case than most people think. But yeah, so next week's talk will be all about Edge and kind of demystifying a lot of that stuff. This SC start finally finished because it was deploying stuff. So you can see we have, well, no, this didn't work. Let me actually add this to, all right, this doesn't go here. This goes in schema. Types, task, or what did I call this? This types. We built it. Now let's check the schema. We have our, full nice extracted schema. Our tasks, our users, our projects, our queries for getting articles, that was already there for projects. The question around this folder has ElectroDB stuff, so I'm confused. Yeah, so this talk wasn't about the ElectroDB parts, it was just about general structure of your project. This order actually does have the ElectroDB stuff in here. I just deleted the article concept, but you can see all of that's here. Okay, cool. So that's all. Anyway, so to summarize, domain-driven design, the starter pretty much sets you up to do it well. If you watch this talk, it'll kind of break down why it makes sense and how to use it. Next week, I'll be talking about Edge. But yeah, that is all I have for today. And thanks for joining, and have a good rest of your week, everyone.